Hello, Dr. Hamdan. I'm Hamad Ilyas, and in this video I will show you what I did to get the project running. So first of all, I opened ansys, workbench, 17, and as you can see here, there was nothing displayed, so I had to go to where was it? Toolbox, reset workspace, double click, and then go to fluid flow, fluent. Okay, so afterwards you get this window when you click Fluid Flow Fluent. You have these options: geometry, mesh, setup, solution, results. We're gonna start with the geometry to create the shape of the nozzle, because I'm doing the diverging converging nozzle, the fluid flow through diverging converging nozzle. Okay, so what we want to do here is click the XY plane, make it 2D, go to sketching, click on line or polyline. Polyline is easier, so we don't have to keep on clicking. Now we're gonna just set the inlet. This is the throat, the outlet or exit. Once we click here, you want to make sure that it's as close as possible. Okay, so right click and make sure to press close to clear up any holes. Afterwards, we're gonna we can also set the dimensions here. For instance, if we go to length, distance, and click here and then here, we're gonna get the distance between the inlet and the outlet. We can edit it from here. But for now, to save time, I'm not gonna do it. Afterwards, I'm gonna go to concept, surface from sketches, to create a surface. So click on any edge of the nozzle, then press apply. Once it's highlighted in blue, we can go to generate. It should generate a surface. Okay, so now we have the geometry. We go ahead and close this window. It's going to be saved it's going to be saved here now, as you can see from the check. Now we're going to start with the mesh. We're going to wait for it to load. Okay. The shape should come anytime soon. Alright, so change it back to 2D. Click on mesh, insert, face meshing. You click here, then no selection, apply. Afterwards, you go back to mesh, you insert sizing. You're gonna have two sizings here. One is for the inlet and the exit, and one's gonna be for the walls, which is gonna be 4 edges and 2 edges for the inlet and exit. So we're gonna start with the inlet and exit. Hold on, no, we have to go here, click, so we can just click on the edge, yeah. And then click apply, as you can see 2 edges. And change this to 0.25. And then we're gonna go and create another sizing and name it, it's gonna be for the walls. Apply 4 inches, yep. 0.1. Okay, and now we should just rename this. Inlet. And rename this one to exit. Okay, and here, highlight all these, name them to wall. Now that we have the sizing, we named everything, go to mesh again, we go to insert, refinements. Just click on this, apply. Make sure the whole thing is highlighted. Afterwards, we can generate the mesh. It's progressing. Oh, as you can see, it's finished. And this is the shape of the mesh. We go to close, meshing, it's already saved here. And now we're gonna start with the setup. So once you get the mesh, you should update. It's already updated, so. But I forgot to set it to 2D, so we should do that now. And then you go to the setup. Hold on 1 second. Okay, setup. Set it to double position and serial for the processing. And then okay. We wait for it to load. Allow access. Okay, so we have two windows here. One's for the mesh and one's for the code, the console. We want to change the type to density base. And then go to models. You want the energy equation to be on. And you go to the viscous, you want it to be inviscid. Okay, so afterwards we go to the materials. Click on the air. We want the air to be ideal gas for the sake of this project. We have to click on change and create because I forgot to do it the first time and I experienced errors. Then we go to reference values. We're going to compute from the inlet. And then you go to boundary conditions. Go to the inlet. We're going to calculate the pressure. We keep it as absolute. We're going to go for 11,000 for this case. 1100,000, I mean, sorry. Supersonic pressure to be 100,000. We press OK. We go to the exit. Change it to pressure outlet. And the gauge pressure, we want to change it to 4,000. Okay. The operating conditions, we change this to 0. And then we go to solution initialization. Go to standard. Compute from inlet. Initialize. After initialization, we go to run calculation. We change the number of iterations to... when I first did this, I made it 2,500, but I got the converging values to be at the 700th iteration. So I'm just going to put it to 1,500. Then calculate. This will take a while. As you can see, here is the plot for the conversions and the iterations. Okay, so the calculation is complete, and it took 560 iterations in the case of this trial. Okay, the computer crashed, so I had to open it again. Now that we finished the calculations, we close this. This is the setup and the solution we finished. So we go to results. Now we want to get a contour graph of the pressure. First, let's make it 2D. Okay. Change this to symmetry 1 and make it a variable of pressure. Just make it 100. Apply. Okay, now we have the contour graph of the pressure. What this means is that the pressure is highest at the inlet because the red is the highest, and it begins to change temperature as it reaches the throat. And then it becomes the lowest as it exits the nozzle through the outlet, or exit. To get another contour graph of another variable, you just change this, for instance, to temperature, and it should be basically the same. And velocity should be the opposite, because it enters the nozzle the slowest and leaves the fastest. And this is how I used ansys to do my project.